Hi guys, in today's lesson, I'll be teaching us thermodynamics under thermochemistry. And I know you guys don't want to miss this. If you have not watched my previous videos on energy changes, I want you guys to watch my previous video. So let's get started with today's lesson. Now, please take note that the word thermodynamics can be divided into what? Into two. Now, the first part is what? Is thermo. So the first part is what? Thermo. The first part is thermo, while the other part is what? Dynamics. Dynamics. So these two words constitute to form the full word thermodynamics. So thermodynamics can be divided into two. The first part is thermo, and the other part is what? Dynamics. So please take note of this. Now, please take note that this thermo means what? Heat. Thermo means what? Heat. Heat, or what? Or energy. So please take note that thermo means what? This thermo means what? Heat or what? Or energy. While this dynamics means what? Change. Means what? Change. Change or what? Or movement. So please take note that dynamics means what? It means change or what? Or movement. While the thermo means what? Heat or what? Or energy. And then on, I said that thermodynamics can be divided what? Into two. The first part is thermo, and the other part is what? Dynamics. And I said that thermo means what? Heat or energy. While this dynamics, means what? It means change or what? Or movement. So you please take note of this. Now, having broken this down, now what is thermodynamics? Now, please take note that thermodynamics is a branch of chemistry that studies what? That studies energy changes, heat transfer, and work in physical and what? And chemical process. Now, please take note that thermodynamics is a what? Is a branch in chemistry that studies what? Energy changes. It studies what? Energy what? Energy changes. Energy changes. It also studies what? Heat transfer. Heat transfer. And what? And work in physical and what? And chemical process. So you should please take note of what? Take note of this. Now, please take note that in chemistry, thermodynamics help us to understand. So in chemistry, thermodynamics help us to understand, number one, whether a reaction occurs spontaneously or not. Number two, heat absorbed or released during a chemical reaction. And then the last one, energy changes in what? In a chemical reaction. So in chemistry, thermodynamics help us to understand this first one, which happens to be a reaction occurs spontaneously or not. I will explain this later on. Heat absorbed or released during a chemical reaction, which was about endothermic and exothermic reaction, which I've explained in my previous video before. Then energy changes in what? In a chemical reaction. I know earlier on when I was defining thermodynamics, rather, I said thermodynamics is a branch of chemistry that studies what? Energy changes, heat transfer, and work in chemical and what? And physical process. So please take note that all these are being understood with the help of what? Help of thermodynamics. So you should please take note of what? Take note of this. So from here, we'll be moving straight to basic terms in what? In thermodynamics. So this is the next part that we'll be moving straight away to. So under basic terms in thermodynamics, we have several basic terms, but in the course of today's lesson, we'll be talking about three of them majorly. And then the first one is what? System. So under basic terms in thermodynamics, the first one we're talking about is what? System. We're talking about system, surrounding, and then the last one I'll be talking about is what? State function. So these three basic terms are the terms that I'll be talking about in what? In today's lesson. So I'll be starting with what? With the first one, which happens to be system. Now, what is a system? Please take note that a system is a region where energy changes occurs. So please take note that a system is what? Is a region where energy changes what? Occurs. When I was explaining thermodynamics, I said that thermodynamics is what? Is a branch of chemistry that studies energy changes, heat transfer, and work in what? In physical and chemical process. Now, these energy changes, they cannot just occur like that. they need a system where they can what? They can occur. So that's where systems now comes in. Now we have several types of system, but in today's lesson, we'll be talking about three major type of system, which include open system. Under the system, we have what? Open system, closed system, and then what? Isolated system. So under system, we'll be looking at what these three type of system, which are going to be the open system, the closed system, and the what? And the isolated system. Don't forget earlier on I said that a system is what? It's a region where chemical changes occur. Because these chemical changes, they cannot just occur like that. If they occur like that, part of the changes we have to what? We have to escape to the environment, or we have to escape to the air or to the surrounding around the what? Around the system. So for these changes to occur, they need a system where they can what? They can occur. So under this system, we'll be looking at the open system, the closed system, and what? And the isolated system. Now we're starting first with what? With the open system. Now please take note that an open system is a type of system which exchanges both energy, both energy. Take note of this, energy. It's actually both energy and matter to what? To the surrounding. So please take note that an open system is a type of system that exchanges both energy and matter to what? To the surrounding. Now please take note that this energy can also be heat. So heat can also take place, can also take the position of this energy. Where matter is anything that has mass and what? And occupies space. Then we talk about state of matter, where we have what? The solid, the liquid, and the gas. But our major focus is what? Is on the gas. Now then water vapor, water vapor is also a gas. Now so this matter can also be what? Water vapor. So please take note of that this matter can also be what? Water. Can also be water what? Water vapor. So this water vapor can also take the place of what? Of this matter. Earlier on, I was explaining what? The open system, and I said that the open system is a type of system which exchanges what? Energy and matter to what? To the surrounding. Now please take note that for open system for the open system rather to be able to exchange energy and matter to the surrounding, it therefore means that the system is what? Is open. So I'll be using an illustration to explain this open system. But before I illustrate it on the board, I want to write a chemical equation on the board right now. And this is the equation where we have CaCO3, which happens to be calcium trioxocarbonate 4, decomposed to form CO2 plus CaO. So carbon dioxide and what? And carbon oxide. So please take note of this. Now we use this equation to also illustrate what? The three system. Now I'm explaining the open system. Now I'll be illustrating it down with a small diagram. Now let's say for example that this is the system. Let's say that this is the system. That's for the open system. Now let's say for example that this is the system, and then this reaction is taking place in the system. So it is taking place in what? In the system. And say for example that this is the reaction taking place in what? In the system. Now in an open system, earlier on I said that in an open system, energy and matter are being exchanged to what? To the surrounding. So this is the surrounding around what? Around the system. This surrounding around what? Around the system. Now because the system is open, energy and what? And matter will be what? Will be exchanged to what? The surrounding around the what? Around the system. Reason because the system is what? Is open. Assuming the system was closed, energy and matter, we have no right, or we have no way to escape from what? From the system into the surrounding. But because the system is open, that's the reason why energy and matter, and earlier on I also said that heat can also take the place of energy, where water vapor can also take the place of what? Of matter. So because the system is open, they now have a way of what? Of escaping to what? To the surrounding. Now for example, let's take this reaction for example, where CaCO3 is decomposed to form CO2 plus CaO. Now let's say for example this equation or this reaction rather is taking place in what? In this open system. Now you see this CO2. This CO2 is what? Is a gas. Why this CaO is what? Is solid. Even these ones, this calcium trioxide before is also what? Is also solid. Now, just imagine that this reaction is taking place in this open system. Now, because it is taking place and the system is open, you see this gas, which happens to be carbon dioxide, will escape to what? To the surrounding. Precisely because the system is what? Is open. So this just explains what? An open system. An open system is a type of system where energy and what? And matter, they are being exchanged, or they are being exposed to what? To the surrounding, because the system is what? Is open. It is not closed. The system is what? Is open. Now, in an open system, you cannot attain equilibrium, because some of the particles what? Will always escape, will always be exchanged to the what? The surrounding, around the what? Around the system. Particles like gas, like you see this one, this carbon dioxide, for example, now that is good, that is into reaction in this open system, will be exposed, will be exchanged to the what? To the surrounding, because the system is what? Is open. So this is all about what? About open system. Please, if you find this video very helpful, I want you to subscribe to my YouTube channel as Divine Online Chemistry Tutorial. Don't forget to like my video, don't forget to share, and don't forget to what? To comment to my video. So let's continue with the lesson. So from here, we'll be moving straight to the next system, which happens to be what? To be closed system. So from here, I'm moving straight to what? To the closed system. Now, what's a closed system? Now, please take note that a closed system is a type of system whereby energy, you see this energy is being exchanged with the surrounding of the system, whereby the matter is being conserved in the system. I'll be using an illustration to also explain on the board right now. But just please take note that in a closed system, the energy is only being exchanged with what? With the surrounding, whereby the matter is being conserved in what? In the system. So for example, let's say this is the system. Let's say this is the system. That's for the closed system now. For the closed system, let's say this is the system. And then for example, let's say this is the system, and then this reaction is occurring in what? In the system right now. Is occurring in the system right now. Now, because it is a closed system, you see any of these particles will not be able to what? Will not be able to be exchanged to the surrounding of the system, because this is the surrounding of what? Of the system. So this is what? The surrounding. So please take note that this word, this is the surrounding. Now, because this is a closed system, any of these particles will not be able to what? Will not be able to evolve from what? The system, because it is what? It is closed. It's what? It is sealed. So please take note of this. So this is the difference between what? A closed system and an open system. An open system is not sealed, it is not closed. But in the closed system, it is what? Is sealed. Now, just imagine that this reaction is taking place in what? In this system. So let's say this is a beaker. Let's say this is a beaker, and then this closed reaction rather is taking place in what? In this system right now. Now, because this system is closed, any of them will not be able to what? Will not be able to evolve away from this system, except what? Energy. And I said that this heat can also take the place of what? Of energy. Now, because this was a closed system, any of them will not be able to what? To evolve from it, because the system is what? Is closed, is sealed up. But despite the system is sealed up, energy will be able to what? To still be evolved from what? From this system into what? Into the surrounding of what? Of the system. So please take note of what? Take note of this. So this is the difference between what? A closed system and what? And an open system. In a closed system, only energy can be exchanged with what? With the surrounding of what? Of the system, whereby the matter is what? Is being conserved in the system. Water vapor can also take the place of what? Of matter. I explained this earlier on. So let's say this reaction is taking place in this system right now. You see this gas. You see this gas. This gas cannot evolve away from what? From this system, because it is sealed up. It is only energy that can evolve from what? From this system. So please take note of what? Take note of this. So from here, we move straight to the last part of what? Our system, which happens to be the isolated system. Now, please take note that in an isolated system, you see both the energy and the matter, they cannot be exchanged. They cannot be exchanged. Unlike the closed system, where only the energy can be exchanged and the matter cannot be exchanged. And unlike the open system, where the energy and the matter can both be what? Be exchanged. But you see, in the isolated system, both the energy and the matter cannot be exchanged to the surrounding of what of the system. And I said that the surrounding is the environment around what around the system, be it closed system, be it open system, and be it an isolated system. I see it right now. So the surrounding around what around the system. But in an isolated system, both the energy and the matter cannot be exchanged to what to the surrounding of what of the surrounding what the system. So please take note of what of this. And the isolated system happens to be what the best system to be used what under chemical reaction. So please take note of what of this, that the isolated system is what happen to be the best system under energy transfer or heat transfer. The isolated system happen to be what the best system, because neither energy nor matter can be what can be exchanged with what with the surrounding. But in the closed system, only energy can be what can be exchanged, whereby in the open system both the energy and the matter can be what can be exchanged to what to the surrounding of what of the system. So please take note of what take note of this. So from here we'll be moving straight to what to the surrounding. So please take note that the surrounding refers to everything outside the system that can interact with what with the system. Now I'll be using this one to explain the surrounding very well. Know this for what for a closed system, and then I say that this area around the closed system happens to be what the surrounding. Now I'm not explaining what the surrounding under what basic terms in thermodynamics. Now please take earlier on, earlier on I said that the surrounding is what the surrounding refers to everything outside the system that can interact with what with the system. So this happens to be what the surrounding. It is the place, it is the region around what around the system that can what interact with the system. Now how can it interact with the system? Now during when I was explaining the open system, I said that in the open system both energy and matter can be exchanged with what with the surrounding. For example, let's say for example that energy and matter, both energy and matter escape from the system into the surrounding. It therefore means that the surrounding now contains what energy and what and matter. Right, see it now. So this is a possible way how where the surrounding can what interact with what with the system. So I come again for the last time. Please take note that the surrounding is refers to everything outside the system. Please take note that the surrounding could be air. The surrounding could be what? It could be air. It could be what? It could be air. It could be what? Laboratory. So it could be air, it could be what? It could be laboratory where the experiment is be what is be performed. So anything that makes energy, only energy to be exchanged with the surrounding, or both energy and matter to be exchanged to the surrounding. It therefore means that the surrounding has what has interacted with what with the system. So please take note of this. So from here, we'll be moving straight to what the last part, which is going to be state function. So we'll be talking about what? We'll be talking about the state function now. And I'll be using what? I'll be using this diagram to illustrate what? The state function. This is just what? This is just what? An open system. So just be using this diagram to what? To explain what the state function. So please take note that a state function refers to what? To the present state of what? Of the system, and not on how the system got to its what? In present state. Now this is what I'll use this system to explain what state function. State function it only just refers to what to the present state of what of a system. Now this is what this is an open system. This is what an open system used for what for a lab work. Now this state function it only just refers to what to the present state of that particular system. It does not talk about how does the system go to get what to that present state, but it only just refers to what to the present state of what of a particular system. That's all about what state function. It only refers to what to the present state of a particular system, be it the open system, the closed system, or the isolated system. It's only just talk about the present state of that system. It does not talk about how does the system get to that present state. So this is all about what? About state function. Now example of state function include, because we have example of state function, they include number one, we have entropy, we have entropy, we have entropy, we also have enthalpy. So number two, we have enthalpy, they also have Gibbs free energy. So these are some of the examples of what? Of state function. So example of state function, we have what? The entropy, we have enthalpy, and then we have what? Gibbs free energy. And when I was explaining state function earlier, I said that state function only talk about the present or the current state of what? Of a system. So please take note of what? Take note of this. So from here, we'll be moving straight to what? To laws of thermodynamics. So please take note of all these. All these are what? Basic terms used in what? In thermodynamics. So we talk about the system. Under the system, we want to talk about the open system, the closed system, and the isolated system. They also talk about the surrounding, that is the environment around what? Around the system. Then we want to talk about the state function, which only talk about the current state of what? Of a system. It does not talk about how does the system get to that what? To that current state it is. It just only talk about what? The current stage of what? Of a system. So you should please take note of what? Take note of this. Then we want to talk about some of the examples, which happen to be entropy, enthalpy, and Gibbs free energy. I've explained all this in my previous video. If you have not watched that video, I am preparing for the 2026 JAM examination. I want you guys to watch that my previous video on how I explained entropy, enthalpy, and Gibbs free energy, and even more. So from here, let's move straight away to what? To laws of what? Of thermodynamics. So this is the next part of what? Of this lesson, which have to be what? Laws of thermodynamics. Now thermodynamics have several laws, but in today's lesson, I think it has 4 laws. But in today's lesson, our major focus will be on the 2 major laws, which happen to be the first law of thermodynamics and the second law of thermodynamics. So we'll be talking about what? The first law, first law, and second what? And second law. So these are the 2 laws that we're talking about, the first law and the second law of what? Of thermodynamics. But we'll be starting first what? With the first law of what? Of thermodynamics. Now what's the first law of thermodynamics? Now please take note that the first law of thermodynamics states that energy can neither be created nor be destroyed, but can be changed from one form to another. So please take note that the first law of thermodynamics states that energy can neither what? Can neither be created nor be destroyed, but it can be changed from one form into another form. So this happens to be what? The first law of thermodynamics. So please take note that this first law, which happens to be this first law, please take note that this first law can also be called what? Or it's also known as the law of conservation of what? Of energy. So this first law is known as what? Law of what? Of conservation of energy. So please take note of this, that this first law is known as what? Law of what? Of conservation of what? Of energy. But the first law states that energy can neither be created nor be destroyed, but can be changed from one form into what? Into another form. Mathematically, the law can be represented like this, where we have delta U equal to what? Q plus W. Are you seeing it now? So the law can be represented like the way we have delta U equals to Q plus W. Where this delta U, please take note that this delta U is equal to what? In change in internal energy. You know delta means what? This triangle sign is called delta. And this delta means change in. So delta means what? Change in. So whereby this U is known as what? Internal energy. So this delta U means what? Change in internal what? Internal energy. Whereby this Q, take note that this Q is what? This Q is what? Is heat. It represents what? Heat. So please take note of this. Now this Q represents what? Heat. Whereby the W is equal to what? Work. So please take note of what? Take note of this. So this equation just simply explain what? The first law of thermodynamics, which says that energy can neither be created nor be destroyed, but can be changed from what? From one form into another form. Some textbooks will say can be converted from what? From one form into another form. It seems the same thing. So you can represent it mathematically like this, whereby this delta U is known as what? Change in internal energy. Then this Q is known as heat, and then the W is known as what? Is work, known as work. So please take note of what? Take note of this equation under the first law of what? Of thermodynamics. So from here, moving straight towards the second law of what? Of thermodynamics. Now please take note that The second law of thermodynamics states that in any conversion of energy from one form to another, there's always a decrease in the amount of what? Of useful energy. So you should please take note of this, that in any conversion of energy, either from one form to another, there's always a what? A decrease in the amount of what? Of useful energy. Now, please take note that when energy is being converted from one form to another, there will always be what? A decrease in what? The amount of useful energy. The energy can never be what? Be 100%. So that's what that law is just talking about. That the energy cannot be 100%. There will always be a decrease in the what? In the amount of useful energy. So you please take note of what? Take note of this. So from here, we have come to the end of what? Of today's lesson. Please, if you find this class very interesting, I want you to subscribe to my YouTube channel at what? At Divine Online Chemistry Tutorial. Don't forget to like, to comment, and also what? To share my videos. Bye, and see you in my next post. Please don't forget that this is a series. This video class is what? Is a series. I talked about energy changes before in my previous teachings, and now in today's teaching, I've talked about thermodynamics and the basic terms used in thermodynamics, and also what? Laws of thermodynamics. And I want you to watch this video, and I also want you to watch my previous video on what? On under energy changes. Bye, and see you in my next post.